Hiya 5. Today we will be learning how to write fractional decimals. So let's have a look at, first of all, at the date. So it's the 1st of February. So if we want to write it as a Roman numeral, and if you're proud, we're going to be having this. Ta-da! Obviously, 1, 2, we have 2 lines. M represents thousands, X represents 10, and then split the 1 again to add it to our X. All right, so let's have a look at our in focus. So our friend here is telling us, sorry if I don't know the name, that's no way I'm going to remember all the names. Our friend here with the ponytail is telling us to arrange the bags from the lightest to the heaviest. Now, as you can see here, we have 3/5 of a kilo, 10/7 of a kilo, 13/20 of a kilo, 17/25 of a kilo, and 31/50 of a kilogram. So that's quite tricky because obviously they all have different denominators. And also, now we want to learn how to put everything into decimals. So what can we do to actually solve this problem, this challenge? So let's have a look. The first thing that we want to do is actually making sure that we can transform fractions in a fraction that we can more easily transform into a decimal. Let's have a look at how we can do that. So what do we know already? So we know already that fractions can be written in different ways but still represent the same quantity. So here, for example, we have 2/5. As you can see, we've got 1, 2, 3, 4, 5 parts, and that's our denominator. And then 2 parts that they are the one that we're actually considering. So we have 2 that are shaded and colored in. So we have 2/5. So 2 represents our numerator. We have the same fraction here, but it's actually written in a different way. So instead of having just 5 parts considered in our denominator, we have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have shaded just 4 of them. But as you can see, it's the same quantity here and the same quantity there. What has happened is that we have split each of these into 2. So we have created double the number of sections. So realistically, what we have done here, we have timed our numerator by 2, and we have timed our denominator by 2. So the rapport between the two is the same. So the relationship is actually the same. So our fractions are equivalent. So we know that the same fraction, as I said, can be written in different ways to make it more practical for us to work with, sometimes for additions, sometimes for subtraction. In this case, it's also important for transforming them into decimal numbers. So we have discovered that if we have 4/10, we can actually say that 4 is divided by 10. Why is that? Because we know that 10/10 equals 1, okay? So 4 tens must be less than 1, must be less than a whole. So what is 4 tenths then? So what is 4 divided by 10? To do that, we have to use our knowledge of the place value grid. Let's have a look, because since 4 times is quite easy, I want to challenge you a little bit more with something trickier, like this. Like we have 31 over 50. So we have to do the same. We have to rewrite our number, our fraction, so that our denominator is going to be more easy to be transformed then into a decimal number. So instead of having 50, we can transform it into a multiple of 10. So we have hundreds. So we do the same for our numerator. So if we have times our denominator by 2, like 50 times 2 to make 100, we're going to do the same with the numerator. So 31 times 2 to make 62. Now we have 62 over 100. This is the same thing here than 4/10. So we know know that 100 over 100 actually equals to 1. So 62 over 100 must be less than 1. Same thing as for 4 tens. So we know that 4 over 10 is less than 1. So must be a decimal number. Same thing here. 62 over 100 is definitely less than 1 because it's less than 100 over 100. So must be a decimal number. So let's have a look how we solve that. There we go. So we have our place value grid, my favorite thing, the place value grid. So we have here 62 represented with our little discs. Obviously, we know that each disc is actually 10. So this is why we know that this quantity is actually 60. However, we only have 6 lots of 10. So we will not write 60 there. Careful. So we have 6 lots of 10 there, 2 lots of 1s, so 62. But we need to divide that by 100. We know that when we divide something by a multiple of 10 or by 10, we're actually moving on the right side of a place value grid. In this case, we're actually going into the decimals. So our jumps are going to be 2 because we are dividing by 100. So this is my first jump and this is my second jump. So my 2 is going to go 1 and 2 and it's going to land there. My 6 is going to go 1 and 2 and it's going to land there. So here I have my 62, horrible writing, sorry. And then here in my units, in my ones, I always have to put a 0, okay? My place value. We will never ever, sorry, have a missing number in our ones. So there's always a 0 there to be a placeholder. Now, obviously, I have marked it myself, but we need to remember that decimal point is always present between 1s and 10s. All right, so now we have learned that 62 divided by 100 is 0.62. So let's go back there. If I move that, again, I know that 62 divided by 100 is 0.62. So what will be our 4 divided by 10? It's going to be just 1 jump, isn't it? So we will have, oh, let's go back. We will have our 4 there. It will just jump here. So we'll have a 4 here. I can try and see if I can write it. I will have my 4 here, my 0 there, and obviously my decimal point there. So here, oops, I know that my 4 tens actually equals to 0.4. If you think about it, also my 2/5 is going to be 0.4 because it's actually an equivalent fraction. Now, let's have a look. So I hope actually I can answer this correct. It's 0.62. Sometimes by mistake I can say 62, or people tend to say 62, 32, 54, but anything that comes after decimal point should be read as 6253 or whatever, never like in tens. That's a bit of a slang, isn't it? All right, so let's have a look. So we know now that this 62 over 100 actually equals 0.662, okay? Now let's have a look at this. If we know that this equals, sorry, just 1 second. So go back here. So now we can compare them properly. So we have found out how to do the 31 over 50. So that will become 62 over 100, so 0.62. So now we can have a look at 7 tenths. So we know that 7 tenths will actually equal to 0.7 because we know well enough that 1 over 10 will be 1 divided by 10, and that's 0.1. Really sorry, I'm so bad on writing with this 1 to 10. There you go. Now we have to look at these are the ones that are a bit trickier. So 3 over 5, so 3/5 can be easily transformed into 6 tenths, and that's easy peasy 0.6. So we have learned that. Okay, if we remember this as our base, calculation, we can also work out the other ones. So now let's have a look at these two. They're a bit more challenging, but not too bad once they're explained. So I think I prepared the first one as 13/20. So what do we know? So what do we know that can actually help us to solve this? So how many lots of 20 do we need to get to 100? Because as we said, it's easier to actually calculate and transform a fraction into a decimal number if we have our denominators as a mod 10 or a multiple of 10. Okay, so what can we do to transform our 20 and make our denominator into 100? Because obviously we can't really go on to 10 because 13 is not divisible by 2. That would be the way to transform 20 into 10. So we can't do that in this case. So how many lots of 20 do we need to get 100? Now let's make it a step back, and a step easier. Let's think about 2. So how many lots of 2 do we need to get to 10? That's something that we know off by heart. So 2 times 5 is actually 10. So consequently, if we make it, one step up, so 10 times bigger, one of the 2 digits, we will have 20, which is the one they're interested into, times 5 will equal 100. So we can do that. So if we do the same thing to the numerator, we will have 13 times 5, that's easy peasy, 65. So obviously our knowledge of its timetable is very useful here, or you can just work it out in the column method by doing 5 times 3 equals 15, and we will have 110 as our exchange, and then 5 times 1 lot of 10 is 5 plus 1 lot of 10 as our exchange, so we will have 65. Okay, then 20 times 5, we just said it equals 100. So our number will be 65/100, so 65 hundredths. So let's have a look. What's going to happen? We just said that 65/100 actually is the same thing as saying 65 divided by 100, because it cannot be 1 yet. It must be a decimal number. So we have 65 here. So we need to jump. It's 1 jump for 10 and 2 jumps for hundreds. So here we are. So our 1 is going to make 1 jump here, and then 1 jump there. It's going to go in the hundreds, and our 10s are going to be 1 jump here and 1 jump there. So it's going to land in the tens. So we have 0.65. So I've been careful there, not to say 65. So 0.65. So that will be our answer here. I hope that it looks decent. Okay, so we have worked out this one here. Okay, so let's have a look now at the one here that looks quite dodgy. 17/25. They are very odd numbers, so we might panic a little. And no, we don't have to, because let's have a look at this. Well, we know well enough that 25 times 2 will equal 50, and then 50 times 2 will equal 100. So basically 25 times 4 equals 100. So we have to do the same here. So we have to do the same with 17. So 17 times 2, we can go in steps. It's not a problem as long as we can do it. 17 times 2 will equal 34, and then consequently 34 times 2 will equal 68. So now we know that we have 68/100, so that will be 68 hundredths. That will again equal to 0.68. Thinking about our jumps, okay, because we will have 6, an 8 there, and then we will have 1 jump for the units and 2 jumps for the units, okay. So we'll have the 8 here, and then we do the same with the 6. Place value, holder, and decimal point there, okay. 0.68. Let's go back here. Now, once we have found out all the answers, we have to consider this. When we are comparing numbers that are with a decimal point, after decimal point, we've got numbers after decimal point, so decimal numbers, there we go, that's the word I want to say. So instead of comparing, for example, 0.6 with 0.62, we could help ourselves by actually putting all the numbers with the same number of digits. So instead of comparing 0.6 with 0.62, we can actually write it as 0.60, and the other one obviously is still going to be 0.62. That's because if you look at that this way, it's fairly easy to see that 62 is obviously bigger. 62 is actually bigger than 60. Okay, so let's continue with our work. All right, now this is our guided practice. Now, in our guided practice, we will have to, let me just check if it's our guided practice. Yes, that's our guided practice. Yes, let me finish the info. So in our guided practice, we will have to write all of these numbers as decimals. Now, a little bit of help here. It could be that instead, obviously, to consider these numbers, or these fractions rather, with the 5 as having a 5 as a denominator, we can transform everything having a denominator that is 10. This way, it's going to be fairly easy for us to immediately see, oh, that's it, that's a decimal number. With regards with the weight here, the kilograms, we have quarters or halves. So again, in this particular case, you can't really go from 4 to 10. So what's the next multiple of 10 that we can use? This one once already. We've used it once already. So you should be able to link that. For our third exercise, we will have to compare the fractions with the decimal number. So what we need to do is actually work out what kind of decimal number these fractions actually represent, and then we can make the comparison. Let's have a look at our worksheet. So same thing here in our worksheet, we will have to write each fraction as a decimal. Now, what you want to keep in mind is the fact that 1/10 is actually equal 1/10, so it can be written also this way, and it will actually equal 0.1, and that's where they would like you to write here. Obviously here, we don't have 1/10, we have 9/10. So how do we change that compared to what I've written here? Finally, we have a little challenge and 2 extra challenges. All right, so the first challenge is to actually maybe recreate these cards here, and you need to make sure that then you arrange them so that the numbers that are touching, a bit like dominoes, represent the same value. They need to be used, they need to be written as you can see as decimals or as fractions. Now, the second challenge, if you want to, is actually create extra lots of cards, not just the ones that are there and the ones that are written there, but create your own. Our third challenge is actually find out and explain if you could actually include in this kind of cards also improper fractions or mixed numbers, and what will happen and why. So in that case, I really would like you to write an explanation in words. Now, as I said, this is the guided practice. That's a bit of help here. There's a bit of help, sorry. This is the worksheet. There's a bit of help there. And this is your challenge. Now, if you think that you're ready for it, you can just continue, actually start your activity there, here and there. Instead, if you think there is be stuck, you can continue watching this video, because there is some extra help here. So let's have a look at the guided practice. Here, as we said, they're telling us different kind of mass, really, the weight of some of these bags. We need to compare them. And to compare them, we actually need to write everything as a decimal. Now, what do we know? So we know here, for example, that we have 1 kilo and 3/4. So we know that 1 kilo is already 1 part of our mass of the weight. So we need to consider 3/4 and transform them into a decimal. What do we know of 3/4? So we said earlier, if you remember, then 4 lots of 25 will equal 100, which is the same as 25 times 4 equal 100. So if we do that for the 4 for our denominator, we need to do the same for our numerator. So we are multiplying 25 by 4. So we also need to multiply 3 by 4. So we are multiplying, my mistake, 4 by 25. So we need to also multiply 3 by 25. So underneath here, I've written, so 3 times 25 equals 75, and 4 times 25 equal 100. So our new fraction, which is equivalent to 3/4, is now 75 over 100, so 75 hundredths. So how do we transform that into a decimal number? So again, we have our 75 here. It's 2 jumps because we're jumping once for tens and 2 for hundreds. So we're going to rewrite our 1 here, our tens there in the tens, and then we have the 0 as a place value holder. So our decimal number will be 0.75 rather. I'm doing that, I don't know. My fault. So I've got it written there. So let's have a look here. Now we know what? We know that we have 1 kilo, and we know that we have 0.75. So we need to put them together, 1 kilo and 0.75. If we put them in a column method, we will have to repeat, the decimal point and the 2 zeros as placeholders to help us with our addition, because sometimes otherwise you can get a bit confused, okay? I'll be there. So if we actually add 0 to the 5, we will have a 5. 0 to a 7, we will still have a 7 decimal point there, not to forget. 1 and 0 is 1. So our answer will be 1 kilo and 1.75 kilograms. So that will be this. Okay, so that's my little bit of extra help for the first part of the better practice. So let's have a look on this on the second part of the better practice. So which number is greater? So 1/5 or 0.5. So we need to transform 1/5 into a fraction with a denominator that is actually 10 or a multiple of 10 to help us. So easy peasy, we can transform it into 10. To do that, we multiply 5 by 2, so that will equal 10, and 1 by 2, and that will equal 2 tens. Now we need to remember this like our own name. Oops, 1 10 equals 0.1. Consequently, 2 tenths will equal 0.2. So clearly now we can see which one is greater between 0.2 and 0.5. That's quite easy now. Now, the 31 over 100. So 31 over 100 is the same as a 31 divided by 100. So we're going to do the usual place value grid. So 31, 2 jumps because it's 100. So we will have 0.31 there. We should be quite familiar with it now. Ta-da. So we can compare immediately and see, oh, well, that's definitely smaller because we don't have any ones there, while we have 3 lots of ones there. So this one is fairly easy because obviously we know this, so we can do that now. And then we have now 11 over 25. So let's have a look here. So we need to transform a fraction with 25 as a denominator into a fraction that has 100 as a denominator. We cannot go back to 10. It's impossible, basically. So as we said, we know that 25 times 4 equals 100. So we will have 11 times 4 equals 44. And 25 times 4 equals 100. So our new fraction, our equivalent fraction to 11/25 is actually 44 over 100. So 44 hundredths. So if we know that we know actually that 44 hundredths is the same as 44 divided by hundreds. So I've got it here. Now we should be masters of this. So our ones are making 2 jumps. So, and then our tens are making 2 jumps. So our new number in the decimal numbers actually is 0.44. And we can actually find it there. And I think that's all I have created for you, year 5. So hopefully this is quite helpful. Please watch the video again and I don't know, I'll write a little message on Tapestry if you're struggling, and we will find a way to get back to you and help you. Thank you very much, and I hope you enjoyed this lesson. Bye-bye.